Hi everyone, welcome to my channel and today I come with another video and this is Enzyme Kinetics, okay, or you can say the Michaelis Menten equation. Clear? So first we learn what is the enzyme and substrate concentration. They are related to the enzyme kinetics. Clear? So actually first we learn briefly what is the kinetic energy. Kinetic energy actually when the molecules present in any substance, they cannot remain stable within this substance. Okay, that you can say solid, liquid, gas, everything. Each always, in case of solid it vibrates, molecules they vibrates, and in case of gaseous and liquids they actually randomly move, and as usually for that reason some kinetic energy produced within the substances. Clear? So here we learn enzyme and substrate concentration. Actually first when enzyme they present within any substrate concentration, actually they react with the substrate. Clear? And the molecules of the substrate and the enzymes, they continuously react with each other to form the ES complex. And this process continuing until the total substrate concentration is totally attached with the enzyme concentration or enzyme molecules, or you can say that enzymes molecules, they actually attached all the substrate molecules that present within the within a substance. Clear? So that means the molecules of the enzymes and the substrate molecule, they react with each other until the concentration of the substrate or the any molecules of enzyme that remain freely. Okay, so then this process or this reaction is continuing. But when the enzyme concentration or the enzyme molecules totally captured by the substrate molecules, or you can say that there is no enzyme molecules present for the further reaction with the substrate molecules, then you can add more substrate molecules within the any container, you can say, but or medium. But as usually enzyme molecules is absent there or occupied by all the substrate molecules that present within the medium, so that's why you can add more substrate molecules but nothing reaction happen. Okay, so here the enzyme kinetics means first we learn for many enzymes the rate of the catalysis B that varies with the substrate concentration. Catalysis B varies. V means actually the velocity. Okay, V means that velocity. So catalysis V varies with the substrate concentration S. Here V means number of moles per second. Okay, and here when the substrate molecules is very small, then V is proportional to the substrate molecules. Clear? That means V is proportional to substrate molecules means the substrate molecule is very less, you can say. Then the velocity that totally dependent on the substrate molecules. Clear? But when the S is high S, that means substrate molecules, number of substrate molecules very high, then V is nearly independent of S. Clear? When the S is small, then it is proportional to S, and when S is high, then V is independent of concentration of substrate. Clear? Now, this is one graph. Here, this way, y-axis, this way the velocity is there, and there is the substrate concentration. Clear? And the this is the hyperbolic, or this is the curve you can see here. I think this is sorry for the disturbance. Okay, so you can see here, this is the hyperbolic curve, and with the substrate concentration when increases, you can see that V also increases. But after sometimes this becomes form a hyperbolic line. Clear? So here actually, and this is the maximum Vmax. This is called the maximum Vmax, and this is the Vmax by 2, half of the Vmax. That's for maximum. So actually, the maximum velocity, Vmax means the maximum velocity, and the substrate concentration here Vmax. Then it that form this type of curve. Why? Because when the velocity is maximum, you can just increase the number of substrate molecules within the medium, but there is no increasement of this graph. That means after the maximum velocity when formed, then the velocity will be never increased as the substrate molecules are added continuously. Clear? So here, this is the reaction that is totally proposed by the Michaelis Menten. The E plus A, E for enzyme, S for substrate. In presence of K1 and K2, it forms ES complex. But this ES complex is not stable and it is obviously reversible. It changes to again. It cannot stable for many times because it either changes to E plus S in presence of K2, or K2 means is here the constant, and the K3 here the constant K3, ES dissociate into the E plus P for product. Okay, ES is not very stable complex. When E plus S reacts with each other, it forms ES complex, but it immediately forms E plus P or the enzyme and product, dissociate into enzyme and product, or it changes again to in this case. Okay, this is generally reversible, but this is not, this product is not again transformed into the substrate. Okay, after the formation of the product, very rare cases, in very rare cases, the product generally not changes to substrate. Okay, so this equation that is proposed by the Michaelis and Menten. Okay, and here the K1, K2 and K3 are the constant. K1, K2 and K3 are the constant. And we here this is the actual theory that the rate of formation of ES complex equals to the rate of dissociation of the ES complex. Clear? This is the actual theory or the principle. So according to this principle, we can say here that K1 ES equals to the K2 plus E3 ES. Okay? K1 E and S concentration, where here the K1 is constant. This is equals to the formation of ES. Here the E and S both present. This is equals to the dissociation of the ES. Here the two constant present. Now you just K1, K2 and K3, it just transform to here. K1 by, or it is divided, K1 ES divided by the K2 plus K3, or you can just change the side. K2, K3, you just transform here. There only remain ES. Okay, there only remain ES complex in the right side. Now you just K1, we just put the K1 below the K2 plus K3. And what happened? You can see that ES in the numerator situation, and this K2 plus K3 by K1, it converts into the Km. Okay, this converts into the Km, and this Km is the Michaelis Menten constant. Clear? Now you can see E and S. You just S transform the S to the denominator of this side and Km to the this side. That means you just transform here E and ES transform to there, and you just again see first right. Okay, 1 second. I'll just write here now. E, I'll just transform ES. Okay, and now Km, write down here, and S. Okay, I just changed the K side to there and ES to here. After changing these two sides, you can see this type of equation. Okay, you can see this type of equation. It is continuing. Okay, this the space is small, so just I write here in up to that. After that, I will write again. So here you can see that E by ES equals to ES complex equals to Km by S. Okay. Now you can I just write here this equation here. Okay. Now we know that the uncombined E concentration. How do we identify or how do we calculate? That is the total enzyme concentration minus the concentration of the ES complex. Clear? So in this way, total enzyme concentration minus the concentration of ES complex, we can calculate the enzyme concentration, that is uncombined enzyme that present within the medium. Now here, this is suppose the equation 2. We just put here this ET minus ES concentration just here. Okay, in the number 1 equation in place of E. Clear? In place of E, because we just here we recognize the uncombined concentration. How we calculate? That is the total ET concentration minus ES complex. So here ES complex concentration. So here I just put here this equation in the number 1 equation's E place by replacing the E concentration right here. This. Now we just how the this equation we know that or we calculate. First ET by ES, you see here ET means total enzyme concentration, ET by ES complex, and in that way ES by ES. So here you can see this become cancelled. Okay, so 1 is there. I write here 1. Now here ET by ES. Okay, and this side Km by S. Now we just transfer 1 with sign minus, that changes to 1 plus. So here you can see the ET by ES equals to the Km by S plus 1. Km is the Michaelis Menten equation constant, that is by S plus 1. So in that way we just calculate up to this part of the enzyme kinetics reaction. Now we calculate how this is related to the Vmax. And here one is important principle or one important theory, that is maximum V, that is proportional to the total ET or total enzyme concentration, because enzyme concentration will stop or the totally occupied by the substrate molecules, then Vmax is the maximum, that is called velocity of the molecule that becomes maximum. After that the velocity never will be increased. So we know that Vmax, that is proportional to the ET. Now we just relate what is the Vmax actually related to the Km. We now just calculate here or we learn here. Clear? You can see here. This is first we just deduce how ET by ES is related to the Km. Okay. Now here it is the relation of the Km and the Vmax. You see here the maximum. You know that maximum velocity, that is proportional to the total enzyme concentration, and also the velocity that is proportional to the ES complex. Okay. So according to this, we can put here the Vmax by V. Vmax by V equals to ET by ES. Just dividing both sides. Okay, dividing both sides. Dividing both sides. Okay, Vmax by V equals to ET by ES. Now Vmax by V equals to Km by ES. How we write here? We here explain that ET by ES equals to Km by S plus 1. So here Et by Es, just replacing Et by Es, I just write down, I write down Km by S plus 1. Okay, this one. Km plus 1. Km by S plus 1. Now, after dividing, or you just calculate with the just LCM process, here you can see that Km plus substrate concentration by S. Okay, and reversing the Vmax and V. Vmax and V, I just write here V in the upper side and the Vmax in the lower side, and here also I just reversing these two upper and lower part. Okay, so you can see here V by Vmax equals to substrate concentration divided by, or Km substrate concentration by Km plus substrate concentration. Okay, now then V equals to, you can say that Vmax substrate concentration divided by Km plus substrate concentration, and this is the relation with the Vmax and Km. Okay, and this equation is totally proposed by the MICHAELIS Menten scientist. Okay, now you can see here the three prospects. Okay, three prospects 1, 2 and 3. When the substrate concentration is very less than Km, this is the equation, and when substrate concentration is very less than Km, then you can see here the relation is V equals to substrate concentration Vmax by Km. Substrate concentration Vmax by Km. That means the velocity that is proportional to the substrate concentration. Okay. Second phase, when the S is much greater than Km, when Km is lower, then we just reject the Km, and here you can see that V is directly to the Vmax. Actually the velocity that increase to the maximum situation or maximum condition when the substrate is greater. In the third category, you see that V equals to Vmax by 2. That means when the S is equal to Km, substrate concentration that is equal to Km. When these are two equal, then the maximum velocity becomes half. Clear? Maximum velocity becomes half. So these are the three categories, and that is totally related to the V and Vmax and Km. So this is the equation of the enzyme kinetics, or you can say that MICHAELIS Menten equation. Now we learn about the MICHAELIS Menten equation, how the we put here. First we describe about the this is the enzyme kinetics theory, and we just learned here the relation between the Vmax and Km. Okay, and the next in my next video I discuss about the double reciprocal plot, and here in case of double reciprocal plot, what is the function of the Vmax and Km, we will learn in that video. Okay, so this is the enzyme kinetics, the first part of the enzyme kinetics we learn here, and I describe all the total topic about the enzyme in my next video, but slowly, because this is a large part and it is not discussed in fully in one video. So this is here I explain about the enzyme kinetics, and in the next video I will describe about the double reciprocal plot. Okay, thank you. And if you like this description or this knowledges, or I just provide you knowledges, so then if you like that, then obviously you like and share and subscribe my channel. Okay, thank you.